Okay, so this is your Unit 4A review. So before I get started, sorry for not being there today. I had something come up, so I'm staying up making this video for y'all. So please make sure you're watching this and you use it. If you watched my video, I'm gonna ask you to do something at some point. You don't know when. Um, and if you send me that something or do what I say, I will add 5 points to your grade on this exam. Okay? All right, so let's see what happens. All right. Okay, so number one. What transformation of the quadratic parent function, right? So we already know it's asking for transformation. So we know this is vertex form, right? Because that is the ideal form you want when you're doing transformations. So a x minus h squared plus k, right? So we know this is a, this is h, and this is k. So what is my transformation? Well, 1/3, if you look at your notes, that would be a vertical compression. So a vertical compression by 1/3. Your h, right, is inside my parentheses, which I already know is always going to be opposite. So because I have a -1, I know that's going to go right 1. And my k is on the outside and it's straightforward. So it's going to go down 4. All right. Number 2. Write an equation of the parabola in vertex form. Yeah, some of it cut off, so I had to go back and fill it in so I knew what it was asking for. Okay, so to write it in vertex form, well, first of all, what is that? So y equals a times x minus h squared plus k. So that's our vertex form, right? So the one thing I know I need for sure is obviously going to be my vertex. So my vertex is right here at 2, 0. So that's hk. Now, I don't know how wide apart this is, right? So my a. So in order to find that, I have my h, I have my k, I need my x and my y. So I need to choose another point. It doesn't matter what point. So I'm going to choose this y-intercept because it's a nice, pretty point. So this is going to be my x and my y and plug it in. So y is 4 equals, I'm looking for a, my x is 0 minus my h, which is 2 squared, and then my k, which is just a +0. So simplify. Right here, we're going to have -2. So a times -2 squared plus 0. I can leave that alone. -2 squared is the same as -2 times -2, which is 4. So 4a equals 4. Divide both sides by 4. A is equal to 1. So that worked out nicely. So my equation is y equals, my a is just 1. So x minus h, which is a +2, squared. And because it's +0, I don't really need to put +0, right? +0 is 0. So then this would be my equation in vertex form. If I wanted standard form, then I would have to do our box method, right? Okay, number 3. Let the graph of G be vertical by a stretch factor of 2, reflection in the x-axis, followed by a transition 3 units down. The graph and write a rule for function G and I identify the vertex. Okay, so we have our original, right? So then that's my original. So it says a vertical stretch, right? So if I stretch something vertically, right, it's going to get taller and skinnier by a factor of 2. So remember, when we're doing transformations, the ideal form is vertex form, right? A times x minus h squared plus k. So if I'm going to change it by a vertical stretch, then I know that 2 is going to have to be my a. And then it's a reflection in the x-axis, so I know there has to be a negative on the outside, followed by a translation 3 units down. So which one of these goes down? My h is left and right, my k. So this has to be a -3. And those are the only transformations it gives me. So my equation is going to be g of x equals -2 times x, right, squared minus 3. Now, the original was x squared, right? Which I know is at the origin. So it started at the origin. It moved down 3, right? 1, 2, 3, which means that my vertex was at 0, 0, but now it's at 0, -3, okay? So right here, you're going to notice that this looks a little weird. Well, that's because in here, right, since we didn't move anywhere, this is still 0, x minus 0, right? So x minus 0 is just x. So I'm going to go on ahead and simplify that a little bit further, right? X squared is just x squared times -2. So -2x squared minus 3. So this would be your equation. G of x equals. Now, your vertex, right, because it's in this format, this came from here, right? And where did this come from? From here. And how do we know this? Because the original was just x squared, right? And that vertex is 0, 0. So the original, this one right here in vertex form, would be x minus 0 squared plus 0, right? So it's just x squared. So my graph didn't shift left or right. So that left and right didn't go anywhere. So it's still at 0. The only thing that happened is that it shifted down, which is why you have to have that -3 there. Okay. All right. So anyway, my vertex is now at 0, -3. All right. 4. Oh, sorry about that. I hit it. Okay. Find the vertex and axis of symmetry. And so first of all, this is in standard form, right? So I know A is equal to 3, B is equal to -6, and C is equal to 1. Remember, always carry the sign. So to find our axis of symmetry, if you use your notes, which remember you can, right? So x equals -b over 2a. So that means that I'm going to have negative whatever b is, which is -6 over 2 times 3. Negative and a negative is a +6. 2 times 3 is 6. So 6 divided by 6 is just 1. Okay. So that's your axis of symmetry. So the only thing you know right now is that at 1, there's an axis of symmetry. Bam. Well, what else do you know? Because I'm lying. That's not the only thing we know. We also know that this is a y-intercept because it's in standard form. So I know that I have a y-intercept right there. What else do we know? We also know that it's going to open up because this is a positive. Okay, so let's find our vertex. Once you find your axis of symmetry, x equals 1 is my axis of symmetry. You just plug it back into the function to find your vertex, right? So you're going to have 3 times 1 squared minus 6 times 1 plus 1. So that's going to be 1 squared times 3. That's 3 minus 6 plus 1. 3 minus 6 is -3 plus 1. -3 plus 1 is -2. So at 1, -2 is my vertex, which means that my graph probably looks something like that. So my vertex is at 1, -2. Ta-da! There you go. Okay. So this one, I'm sorry, because some of you probably had an issue with this at some point. First of all, the original equation made no sense because your A was a positive, right? Which is something I tell y'all to look for all the time. This is obviously a negative parabola, which means your A has to be negative, which didn't make sense with that equation. So the new equation we have created is -2 over 3x squared plus 4x plus 6, which works out a lot better with this problem, okay? So the function below represents the flight of a ball being thrown by who is standing. What is the maximum height of the ball? So the maximum height we know would be somewhere around here, right? which basically means if it's asking for the maximum, we already know we're going to be looking for the vertex, which was literally the problem we just did. Okay, so this is all just by identifying what is it asking for, right? So we want the maximum height. Okay, well, the function below represents the flight of the ball being thrown by who is standing, right? So if I want the maximum height, that means, right? So let's use our common sense. If I'm throwing a ball, this would be the height, right? Which would be y. So I'm going to want the y value of the vertex, right? Which is our k. Okay, so how do we do that? Well, we already know how. We're going to use a -2/3, b 4, and then c is 6. Can y'all see? I hope so. If y'all can, I am so sorry. Okay, so a is -2/3, b is 4, and c is 6. Okay, so to find our axis of symmetry, we know that's going to be x equals -b/2a. And yeah, you kind of need your axis of symmetry if you want to find the y value, right? So you can't really find it without doing this first. So we're going to have -b, which is a +4. Then 2 times a, which is -2/3. All right. So we have -4 over -4/3, which is really just division, right? So we have -4 times, you flip the bottom, -3/4, which would give us a +12/4, which is going to give us just a +3. Okay, so we have our y value is a -3. So my vertex is at, oh no, wait, I'm sorry, that was just the axis of symmetry. So x equals 3. So I know my axis of symmetry is around 3. So to find the height, I need to plug it back into the actual equation, which again, sorry, I changed it on y'all. It's -2/3x² plus 4x plus 6, okay? So we're going to have -2/3, plug in the 3 squared plus 4 times 3 plus 6. So this is really 3/1, right? Oh, I guess that doesn't matter. So 3 squared is 9. So we're going to have -2/3 times, times 9/1 plus 12 plus 6. Then we're going to do, this is -18/3 plus 12 plus 6 is just 18. -18 divided by 3 is 6. -6 plus 18 is equal to +12. So that means that the ball has a maximum height of 12, and it didn't tell me if it was feet or anything, so I'm just going to put feet, okay? So the ball has a maximum height of 12 feet. Okay, that's 5. All right, 6. Write an equation in vertex form for the parabola that has a vertex of -6, -4, and passes through the point -2, 12. So I have a vertex, thank you, and I have a random point, so that's just going to be an x and y. So my goal, right, my goal is vertex form, so that's y equals a times x minus h squared plus k. So that's what I want. Sorry. Okay. So this is the goal, right? So I have an x, a y, and an h and a k. So x, y, h, k. I'm missing a. So I can plug in what I have to find what I need and then put it into my goal form, which all I would need is a, h, and k. So my y is 12 equals, we're looking for a. My x is -2 minus my h, which is a -6. So that's going to be +6 squared. And then my k, which is a -4, so -4. So now we're just going to do some algebra 1. -2 plus 4. Really, we're just order of operations. Is this really algebra 1? Okay, whatever. -2 plus 4 is 4 squared minus 4. Remember, we're multiplying by a equals 12. So 4 squared is 16. So we have 16a minus 4 equals 12. Add 4 to both sides. So that's 16 equals 16a. So a is equal to 1. So it just happens to be 1 again. That was the problem from earlier also. So now that I have a, h, and k, I can put it in my proper vertex form, which is just 1. So I don't need that. So x minus h, which is a -6, so it's going to be plus 6 squared, and then minus 4. This would be your equation in vertex form. Okay, moving on. So again, sorry, got cut off a little bit, but I filled it in. Okay, so write an equation of the parabola given vertex at 3, -2. Okay, so we have a vertex at 3, -2, so that's HK. And focus at 3, 3. Oh, great. So these are our beautiful focus problems with the directrix and everything. So remember, we're going to draw a picture, okay? That's how we're going to figure out if it opens up, down, just by getting a rough draft of what we have. All right, so I'm going to draw just like a normal graph there, whatever. Okay, so let's do our vertex of 3, -2. So 1, 2, 3, 1, 2. So that would be about right here. So there's 3, -2. Let's label that my vertex. And then I'm going to do my focus at 3, 3. Okay. So my focus is at 3. So 1, 2, 3. So at about there, right? So that's my focus and my vertex. So from here, you should be able to tell me if it's going to open up, down, left, right, because we, from class, from last time, right, we have 4 different options, but what you hopefully remember is that your parabola is always going to hug your focus, right? Like the focus of your universe. You're going to be so careful with it, right? So we talked about this in class. You know, the focus of my universe is Cami, right? My daughter. So I'm going to do everything I can to always protect her, right? So because here's my vertex and I know that's part of my parabola. Well, the only thing I know right now is that my parabola has to hug my focus. So I know that this parabola is going to open up. So that's one thing I know. So it's going to open up. So what else does that tell me? Okay, so another thing that tells me is which type of equation I'm going to use. If it opens up, right, that's a vertical parabola, which remember, we're used to having the x being squared, right? This is normal. We've been doing this for a good minute. So this is the equation I'm going to use. So I'm going to write that down. So x minus h squared equals 4p y minus k. Now, let's not forget what it is that we want. In order to use this equation, you want h, k, p, and we already know it opens up, okay? So we have our h and our k. So my vertex is right here. So my h is 3 and my k is -2. The only thing I'm missing is my p. Now, one thing that you should be able to tell me is if your p is going to be positive or negative, okay? Now remember, use your logic, right? We know where all the positive numbers live. They live up and to the right. All of your negative numbers live left and down, right? So this parabola is going up. So what would make sense for your p to be? Positive p or a negative p, right? It's going up towards the positive. So I know one thing, and that p is going to be a positive number, whatever it is, okay? So you could use your chart, right, to figure it out and use the little formulas I gave you, or you can literally just use your little rough draft, right? The sketch we did. Just number your stuff. -2, -1. I know that's 0, 1, 2, 3. And you can physically count, right? So we have 1, 2, 3, 4, 5. So this is 5 units up. So I know my p, which remember is the distance from your vertex to your focus and from your vertex to your directrix. So I know my directrix is obviously somewhere down here. So my p is a +5. So then now you have what you need. So you have x minus your h, which is a 3 squared, equals 4 times 5 times y minus k, which is a negative 2, so plus 2. So we simplify, so we have 20 there, y plus 2, and then x minus 3 squared. Now remember, your answer could look like this and you could be done, right? But you need to look at your multiple choice and look at what type of answer choices they gave you, okay? So remember, if it's a vertical parabola, right? So if you forget, okay, like which equation to use, just look at what you already know. Y equals ax squared plus bx plus c, right? This is what you've used to. This is what we've been seeing since algebra 1. What squared? The x. So if the x is the one that's squared, then that's what you already know. So this is up and down, right? If it opens left and right, then that's going to be the weird one where the y is squared, right? Because you're not used to that. Anyway, we're not done. So then from here, if your answer choices don't look like this, then obviously that means you need to solve for a variable. Now, which variable? The one that isn't squared, okay? So if this one's squared, not this one, you want this one. So you're going to divide by 20 to both sides. So we know we have a 1 there, so that would be 1 over 20. X minus 3 squared equals y plus 2. Subtract 2 to both sides, so y equals 1 over 20, x minus 3 squared minus 2. Now remember, your this should still match your original vertex, right? So we know h is always with x, which is a negative 3, so it's really opposite because it's inside parentheses, so it's going to be a positive 3, and then this would be a negative 2, which would be your k. Okay, so your equation could be either one of those. All right. Number 8, write an equation of the parabola given. Okay, so again, but now we're given different features, right? So what's the first thing we're going to do? Well, we're going to draw a sketch before we start trying to figure out what we're going to use. Okay, so we have a directrix at y equals 7. Now remember, anytime you have a variable that just one, right, a y or an x, we like to think of the acronym HOI-VUX, right? So this is y, which I know is HOI, which means I'm going to have a horizontal line at y equals 7. So here's y, 1, 2, 3, 4, 5, 6, 7. So I'm going to have the directrix right here. Directrix at y equals 7. Okay. And I'm going to have a focus at 0, negative 7. Okay. So here's 0, 1, 2, 3, 4, 5, 6, 7. So this is negative 7. And then this is going to be my focus. Okay. So these are kind of far away, right? Now remember, the first thing we want to try and figure out is what formula am I going to use? What do I have? What do I need? Okay. So remember, in order to use either one of these, right, you need the same 3 things every time. You need an H and a K, which is your vertex, which this problem did not give us. They gave me the directrix and the focus, but we know how to find the vertex. Okay. So H, K, and you have to have P. Okay. So remember, your vertex is going to be in the middle of both of these things, right? So remember, from 0 to the directrix is 7 units, and from the origin to the focus, it's negative 7, right? So this one's kind of like an easy one because you can kind of just look at it and figure out where your vertex is actually going to be at, right? So it's actually at the origin, because it's 7 units away from both. Now, here's your vertex. To figure out if it's going to open up or down, remember, it has to hug your focus. Because my focus is down here, then I know that my parabola is going to be opening down. So it's going to open down, which is going to make it a vertical parabola, right? So we're going to be using this equation. So we're going to use x minus h squared equals 4p times y minus k. All right, so so now we have an h and a k, right? Our h and k is at the origin, which is 0, 0, And you were probably even able to figure out your P, right? You just by counting 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, right? Now, you need to know if that's going to be a positive 7 or a negative 7. Now, remember, this is where your like mathematical logic comes in, okay? If it's going down, what's down? Positive numbers or negative numbers? Negative. So your P is a negative 7, okay? So now we can plug everything in. So we would have x minus 0 squared equals 4 times negative 7, y minus 0. Now let's simplify, right? So you're going to have negative 28. Y minus 0 is really just y, okay? Then equals x minus 0 is really just x squared. We want to isolate the y, right? So we're going to divide both sides by negative 28. So remember out here, we really just have a 1. So that's negative 1 over 28 x squared equals y. And then obviously I like the y on the left side. So let me just go on ahead and fix that. So that would be your equation for the parabolic function for that one, okay? All right, moving on. 9, find the directrix of the parabola given vertex at, so we have a vertex, that's great to know. So I know this is HK and a focus at negative 2, negative 3. It cut off, but it's negative 2, negative 3. So again, I just find it easiest to draw a picture so I can visually see what it is that I need, have, and want, okay? So find the directrix of the parabola given the vertex negative 2, 2. Okay, so negative 1, negative 2, 1, 2. So negative 2, 2, which is right there. Okay, so that was my what? My vertex. Okay, so I have a vertex. Cool. And focus at negative 2, negative 3. Okay, so negative 2's here. Negative 3, 1, 2, negative 3 would be about there. And that's my focus. Now remember, you want your vertex, you want your parabola to hug your focus. My focus is here, which means my parabola is going to open down once again. Okay? Now, except here, I don't really care. I just want a directrix, right? So I just need to figure out how far away is my vertex from my focus so I can do the same thing to the other side. So we know this is 2 and this is negative 3. So literally all we have to do is count. So 1, 2, 3, 4, 5. Ta-da, 5 units. Now in this case, because we don't want an equation, it doesn't matter if it's a positive 5 or negative 5. You should be able to tell me if it's a positive 5 or negative 5, right? Because it's opening down. But it doesn't matter because I just want the directrix. I just need to count 5 in the other direction. So let's go. So 1, 2, 3, 4, 5. So if this is 2, 3, 4, 5, 6, 7. So that means we have a directrix at, what type of line is this? This is a horizontal line. So I know I have to use the value y, or the variable y. So y equals 7. So our directrix is at y equals 7. Okay. Then we have 10. Write an equation of the parabola given characteristics. Okay, so it's going to open down. It's going to have a vertex at negative 1, negative 3, and 2 units from the focus. All right, so let's draw that out first, okay? So write an equation of a parabola. So vertex, which is our HK. Let's go ahead and draw a picture. So my vertex is at negative 1, negative 3. So negative 1, negative 3, 1, 2, 3 would be right about there. Okay. Oh, this is my vertex. Let's label that. Okay. So write an equation. And I already know it opens down because it told me, right? So if this is my vertex, it's going to go something like that. 2 units from the focus. So if I already know it opens down, then this is negative 3, negative 4, negative 5. So my focus is going to be down here, right? Okay, so then what does that tell me? Now remember, it's asking for an equation, right? So that means that I need to know which one I'm going to use. Well, I know that it's opening down, so that means I have to have the x term be squared for p times y minus k. Now, in order to fill this in, I need three things. I need an h, a k, and a p. I already have my h and my k. That's my vertex, so -1 and -3. Now for my p, that's the distance from my vertex to the focus, which they told me it was 2. So I guess I really didn't need to draw anything, but it made me feel better, so it's cool. So 2 units. Now, do not get confused. It's telling you it's 2 units from the focus, but you need to know if this is going to be a +2 or -2. This parabola is opening down, which is what they told us, which means your P is a -2, not a positive. So now we can plug in our information to get our equation. So x minus, but this is a -1, so it's going to be a +1 squared, 4 times -2 y minus, but it's already a negative, so +3. And then you can solve for y, right? Just again, it depends on what your equation looks like. So this would be x plus 1 squared, -8, y plus 3. So this could be your answer, or you could go on ahead and isolate for the variable that isn't squared. So this one isn't squared, so I'm going to divide by -8. So -1/8, x plus 1 squared equals y plus 3. Isolate the y by subtracting 3 to both sides. So you're going to end up with y equals -1/8 x plus 1 squared minus 3. Okay, so your answer can be either one of those. Alrighty. 11. Write an equation of the parabola given these characteristics. Okay, so you gave me, or I'm giving you a graph. And what do we know? Okay, well, let's see here. We have a directrix at x equals -2. We have a vertex at the origin, and we know that it opens right. So if I want to write an equation, so it opens right. I know my vertex is at 0, 0, so let me label that. My directrix is at -2, right? This is -2, which means it's going to be 2 units away. Okay, so that's helping me. So this is 2 units away, right? Now, we need an H, a K, and a P, which we pretty much almost have. So remember, your vertex is HK, right? So 0, 0. Now, your P, you need to know if this is a positive P or a negative P. It's opening to the right, which means it's going to go towards your positive numbers, right? So this is a +2. So then now we can use our equation for horizontal parabolas. So because it's horizontal, right, it's not going to be x squared. The y is going to be squared. So we're going to have y minus k. And remember, y and k always go together, right? Just the way x and h do. This is the one that's going to be squared. Then 4p times x minus h. Now I can plug in what I know. So I'm going to end up with y minus 0 squared equals 4 times p, which is 2, right? So 4 times 2, x minus 0. So y minus 0 is just y squared equals 8 times x. So if you, ideally we want to have the variable that's not squared isolated. So I'm going to divide both sides by 8. So there's a 1 there. So 1/8 y squared equals x. So x equals 1/8 y squared. That would be your equation. Okay. 12. Write an equation of the parabola in intercept form. So what is intercept form? Okay, so that's y equals a times x minus p, x minus q, where p and q is your intercepts. So here we can see we have 2 of those, right? So this is at 0, 0. So I have one x-intercept at 0, 0. And then I have the other one at 2, 0. So we have P equals 0 and Q equals 2. So I can just plug those in. So y equals a x minus 0, x minus 2. Now, what's wrong here? I don't have an equation all the way. I'm still missing an a, right? So what can we do? We can go on ahead and substitute x and y with any ordered pair on here. Literally any. So I'm going to choose the vertex because it's still an ordered pair, right? Which is, what is that, 1, 2? Sorry, I did that wrong. 1, 2. So I know x is 1 and y is 2. So a, 1 minus 0, 1 minus 2. Now the only variable I have left over, can y'all see that? The only variable I have left over is a. So we have 2 equals a times 1 minus 2 is negative 1. So you're going to have negative 1a equals 2 wait, did I do that right? I think so. Let's find out. Divide both sides by negative 1. So you're going to end up with a equals a negative 2. Hopefully I did this right. Sorry, guys. I'm tired. I think I did. Yeah, I think I did. I'm gonna say I did. Okay, well, let's go back with my reasonableness, right? This is opening down, so no, you know your a has to be a negative, which it is. So I'm gonna assume I did it right. If I didn't, y'all let me know. So y equals negative 2 x minus, remember my first one was 0, and then I have x minus 2. Because this is x minus, then do I really need the 0? No. So y equals negative 2 times x minus 2. And then again, I don't really need the parentheses anymore, right? Negative 2 times x is just going to be negative 2x times x minus 2. Now it's simplified a lot better, right? And remember, it said intercept form, right? It said intercept form, so this is the simplified intercept form. What makes it look a little weirder is the fact that one of your x-intercepts was at 0. So it may not look like intercept form to the naked eye, but that's just because we simplified it, right? And we got rid of these set of parentheses because they weren't needed anymore. So this would be your intercept form. 13. Write an equation of the parabola in intercept form. Given the x-intercepts 9 and 1 passes through 0, 18, negative 18. Yeah, that was weird. Okay, so we know we have the two x-intercepts 9 and 1. So P equals 9 and Q equals 1. So I know I want it in intercept form. Oh, you can't see. There we go. So y equals a times x minus p, x minus q. So what do we have? Now it passes through this ordered pair. So let's plug everything in because that's pretty much what's going to happen, right? The only thing I don't have is my a. And I literally have everything else except for my a. So negative 18 equals a. Your x is 0 minus your 9. And then x is 0 minus your 1. So let's simplify. So we end up with negative 18 equals a times negative 9 times negative 1. So that's 9a, right? Negative 9 times negative 1 is 9 times a, negative 18. Divide both sides by 9. So negative 2 is equal to your a. So a equals negative 2. So now that we have that, we can just plug everything in. So we would end up with y equals your negative a, which is negative 2 times x minus 9, x minus 1, which this is the traditional intercept form that you're used to seeing. Okay. All right, 14. Find the maximum or the minimum value of the functions below. I wish this one would have been 1 and 1, but it wasn't. So whatever. Okay, so what do we know about these functions? So the first thing I want us to remember is that, so let's do this one first, right? So this one has x squared minus 3. So they mimic ax squared plus bx plus c. But from the other day on the notes, it's missing the b term, right? There's no x, that's just x. We have an x squared and we have a constant, but there's no bx term. So to find the maximum or the minimum, right, which pretty much maximum, minimum, we already know what that means. That means vertex. So you could find the vertex by doing negative b over 2a. That is an option, right? X equals negative b over 2a, because technically this is standard form, technically. Or because the b term is missing, you know that you can add parentheses right there, right? Because what's really in there? X minus 0 squared minus 3. Here's your h, here's your k. But this trick only works if the b term is missing, okay? So your vertex would be at 0 comma negative 3. Now, minimum or maximum? Well, that's simple. You just look at your a, which is a positive 1, so it opens up. So it makes it a minimum, okay? Now, yes, you could have just used this, right? So negative b equals negative 0, which is really just 0 because there's no b, right? A is 1, b is 0, and c is negative 3 over 2 times 1. So 0 divided by 2, that's 0 over a number, which is always going to be 0 because it's on, okay? So that's fine. So x is 0, which is exactly what we got down here, right? And if you plug 0 back in, well, 0 squared is 0 minus 3, negative 3, which is exactly what we have. So same process here, right? You should be able to do that on your own now. All you do is add your parentheses because the b term is missing. That only works when the b term is missing. So you would have x minus 0 squared plus 1. So here's your h, here's your k. So again, it's opening up because your a is 1. So this would be a minimum at 0, 1. Okay. Yeah, y'all can see that. And again, if it's in standard form, as long as you can identify your a, b, and c, you could just do negative b over 2a, find that, and then plug it back in. Okay? All right. Now, for these last two problems, I did have a few emails actually asking about this. How am I going to do this if I'm not at work? Okay. Because I realized that I didn't show y'all how to do it on Desmos on the okay, so okay, so what I'm gonna do is that I'm gonna stop the video now, and I'm gonna have, so you should see a second video, and that second video is gonna have 15 and 16 where I'm sharing my screen, and we will do it using Desmos since that's the one I didn't show y'all how to do all the way through on the notes the other day. Okay. Yeah, okay.